Welcome sa course na Mathematics. Solve naman tayo mga sample problems sa probability. So first problem, a restaurant has of its dessert menu 4 kinds of cakes, so 2 kinds of cookies, and 3 kinds of ice cream. So find the number of ways a person can select una, one of the desserts, and then isa pa, find the number of ways a person can select, so for B, one of each kind of dessert. So yung una, meron daw na 4 na kinds ng cake. So denote lang natin, pwedeng sabihin natin na yung cake number 1 yung nasa pinakataas, cake number 2 sa pangalawa, sa baba, and so on. Tapos dalawang kinds ng cookie, so cookie number 1 tsaka yung cookie number 2. Sa ice cream naman, so 3 kinds ng ice cream. So ice cream 1, ice cream 2, and ice cream 3. So para sa unang tanong, find the number of ways a person can select one of the desserts. So yung ibig sabihin ano yung or gaano karami yung ways in which makakapili siya ng isa dun sa mga dessert na yan. So hindi natin concerned kung anong kind ng dessert yung pipiliin, basta isa lang dun sa lahat ng dessert na nabanggit. So simply pag-aadin lang natin sila. So 4 plus 2 plus 3. So ibig sabihin merong 9 ways a person can select one of the dessert. Para naman sa pangalawang tanong, so gagamitin natin yung concept, pwedeng gamitin yung concept ng tree diagram na tinatawag. So for example, para dun sa unang option, kung nakapili na ng isang cake, so dalawa na lang yung option niya for cookies. For example nga, yung una, kung napili yung cake number 1, so, and then dito napili rin yung cookie number 1, tapos yung ice cream number 1. So, isang way na yon ng pagpili ng one of each kind of dessert. So, isang cake, so cake number 1, cookie number 1, pati yung ice cream 1. Pwede rin naman na cake number 1, cookie number 2, pati yung ice cream 2 yung piliin. So, isang way na rin yon. So, pwedeng bilangin yan lahat. So, yan naman na nakalagay sa tree diagram, pwedeng bilangin, and so on and so forth. So, pag binilang niyan, meron kang 24 ways to choose one of each kind of dessert. Or, pwede rin naman yung concept, diba, yung sa pwedeng ipag-multiply or yung product rules sa fundamental principles of counting. So, yung mga options, yung multiply lang. So, 4 times 2 times 3. So, 4 times 2 ay 8. Then, times 3 ay 24. So, next problem. Suppose a password consists of 4 characters where the first character must be a letter of the English alphabet, but each of the other characters may be a letter or a digit. So, find the number of passwords, and then find the number of passwords beginning with one of the vowels. So, para sa unang unknown, so gaano daw karami yung passwords na pwedeng mabuo, in which yung gamit na characters, so 4 characters, tapos yung unang character must be a letter of the English alphabet, tapos yung second, third, and fourth character ay pwedeng letter or a digit. So, pwedeng 4 na A or pwedeng pumili na lang. No? So, yung una, A to Z. Yung pangalawang character ay A to Z tapos 0 to 9. Yung pangatlo, pati pang-4, ganun din. So therefore, yun sa una, dahil nga A to Z, meron kang 26 options or 26 ways or 26 characters na pwedeng pagpilian. So gagawin doon, may pag-multiply ulit sila ng lahat ng mga options. Tapos sa pangalawa, 36. And then pangatlo, pang-4. So 36 din lahat. So therefore, number of passwords ay 26 times 36 cube, or so 26 times 36 cube, ayan, or 1,213,056 passwords yung pwedeng mabuo. 4 na characters, yung una ay letter, tapos yung second, third, and fourth ay pwedeng character na letter or digit. Yung next naman, find the number of passwords beginning with one of the vowels. Therefore, yung unang character ay 5 lang yung options na pwede. Yung pangalawa, pangatlo, pang-4, so pare-parehas na 36. Therefore, 5 times 36 cube So 5 times 36 cube ay so 233,280 yung passwords or number of passwords beginning with one of the vowels, and then the rest ay letter or a digit. So next naman, a group of musicians is composed of 3 drummers, so 4 trumpet players and 5 pianists. In how many ways can a trio be formed consisting of 1 drummer, 1 trumpet player, and 1 pianist? So, ganun din. So, ipag-multiply lang natin yung mga options para makapili ng one of each kind. So, 1 drummer, 1 trumpet player, and 1 pianist. Therefore, 3 times 4 times 5. So, 3 times 4, 12 times 5 ay 60. Next naman, so itong notation na to, di ba? So, permutation. Some permutation, any arrangement of a set of n objects in a given order is called a permutation of the objects taken all at a time. So any arrangement of any r which is less than or equal to n of these objects in a given order is called an r permutation or a permutation of the n objects taken r at a time. So ito yung mga notations na pwede nating makita para dun sa permutation. So, yung una, so, ang pagbabasa na, so, permutation of n objects taken r at a time. So, p and r. Or yung notation niya sa calculator, so, npr. Or equal to, diba, sa n factorial over n minus r factorial. In which yung factorial, ganito yung notation. Or pwedeng pabaliktad sila. So, 1 times 2 times 3 times 4 and so on hanggang sa n. Or n papunta sa 1. So, pwede na natin sagutan to based dun sa concept na yun. So, n factorial. So, yun yung unknown. Yung nasa left side. Yung permutation of n objects taken 6 at a time. So, ano yung n? And then, equal daw siya sa 3 times permutation ng n objects taken 5 at a time. So, n factorial sa left side over n minus 6 factorial equals sa 3 times n factorial over n minus 5 factorial. So, divide both sides na lang sa n factorial tapos multiply both sides sa n minus 5 factorial kaya magiging ganito yung form niya. So, n minus 5 factorial over n minus 6 factorial equals sa 3. So, yung n minus 5 factorial, di ba? 1 times 2 times 3 and so on. So, n minus 7, n minus 6, and then n minus 5. So, hindi natin alam kung ano yung n. So, ganito yung assumed notation natin. So, hanggang n minus 5. Next naman, so n minus 6. So, 1 times 2 times 3 and so on, n minus 7 times n minus 6. So, nakalagay, di ba? Pag divide natin, n minus 5 factorial over n minus 6 factorial. So, therefore, cancel lang yung mga yun. Yung n minus 6 factorial. So, matitira na lang ay n minus 5. Kaya, matitira ay n minus 5. So, n minus 5 ay equal to 3. So, add both sides ng 5. So, therefore, n ay equal sa 8. So, next problem naman. So, ito naman yung permutation ng mayroong mga repeated. And so, find the number of n permutations that can be formed from all the letters of each word. So, yung una ay Q, committee, proposition, tapos baseball. So, permutations of n objects in which n1 are alike, n2 are alike, and so on hanggang n are alike. So, ganito naman yan. So, n factorial over yung n1 factorial times n2 factorial and so on hanggang n sub r factorial. So, pwede na nating isolve to. So, yung una, which is yung Q. So, yung letter Q equal sa isa lang. So, isang instance lang siya. Yung U naman, so dalawa. Yung E, dalawa din. So, merong magkatulad. And then, N ay equal to 5. So, therefore, substitute natin sa equation. So, 5 factorial, yun yung total number of objects dun sa, or letters dun sa word na Q. So, 5 factorial over 1 factorial yung para sa Q. So, 1 lang din naman yan. So, nilagay ko na lang. And then, 2 factorial times 2 factorial. Therefore, 5 times 4 times 3 times 2 times 1. So, maka-cancel yung 2 times 1 sa dulo, tapos yung 2 factorial dun sa baba. Therefore, 5 times 4 times 3 over 2 ay 60 over 2 or 30. So, 30 permutations from all the letters ng Q. Para naman sa committee, so isang C, isang O, dalawang M, isang I, dalawang T, tsaka dalawang E. So, total number ay N. So, kaya 9 factorial over yung sa C, O, M, I, T, E na magkakatulad kung ilan yung dami. So, product nun na naka-factorial. So, ganito yung form. So, therefore, 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over yung 2 times 2 times 2. So, therefore, merong 45,360 permutations from all the letters of the word committee. Next ay proposition. So, dalawang P, isang R, tatlong O, isang S, dalawang I, isang T, tsaka isang N. So, total number of letters ay 11. So, kaya 11 factorial over. So, hindi ko na sinama yung mga 1. Yung mga 1 factorial kasi 1 lang naman yan. So, 2 factorial, 3 factorial times 2 factorial. So, therefore, ito naman yung form. Cancel naman yung mula sa 4 na yung nasa taas. So, 4 times 3 times 2 times 1. So, ganun din yung value nung nasa denominator. So, yung 3 times 2 times 1, sa tulad naman, and then yung 2 times 2 sa denominator ay equal sa 4. Kaya, ito na lang yung matitira. So, 11 times 10 times 9 times 8 times 7 times 6 and times 5. So, therefore, 11 times 10 times 9 times 8 times 7 times 6 and times 5 ay 1,663,200. Next naman, yung last na dito ay yung sa baseball. So, may dalawang B, dalawang A, so isang S, isang E, tapos dalawang L. So, total number of letters ay 8. So, 8 factorial over 2 factorial, 2 factorial, and then 2 factorial. So, and kaya, so 8 times 7, 6, 5, 4, 3, 2, 1. Then, over 2 times 2 times 2. So, 5,040 permutations sa letters na baseball. Next naman, so find the number n ways 5 large books, 4 medium-sized books, and 3 small books can be placed on a shelf so that all books of the same size are together. So, dalawa yung parameters na dapat i-consider. So, hindi lang kung ano yung total number of ways na pwede silang i-arrange. So, kasama din yung isa pang consideration na dapat magkakasama kung tulad-tulad silang large, medium, or small. So, kagaya nito, no? So, pwedeng i-arrange na kagaya kanina na nasa leftmost part yung large size book, nasa gitna yung mga medium size books, tapos nasa right side yung small books, in which meron yung isang arrangement, tapos yung within itself, no, yung pagkaka-arrange ng mga large books na magkakasama sila. So, isang arrangement pa rin yan. So, kagaya na to. So, pwedeng nasa gitna yung large book, yung nasa left side yung medium-sized book. Tapos, isa pang arrangement kung gaano karaming ways kung paano sila i-arrange itself within yung group nila na medium-sized books. Kaya may paggalaw na naganap, di ba? Yan. So, isa rin yun. And so on pa. And so on, kung gaano karaming ways. So, pwede nating sabihin na yung pagkaka-arrange ng large, medium, small. So, meron kang tatlong options. Pwedeng large, medium, small, large, small, medium, medium, small, large, medium, large, small. Tapos yung small, medium, large, or small, large, medium. Pwedeng sabihin na 6 ways yun. Arrangement na magkakasama sila. Or pwedeng sabihin na 3 factorial, di ba? 3 options. Tapos within itself, so merong 5 large books, so 5 factorial, 5 factorial ways. Kung gaano karaming arrangement yung pwedeng mabuo within itself, no? Within the group ng 5 large books. And then 4 factorial para sa medium-sized books, tapos 3 factorial para sa small-sized books. Kaya, ayan. So, 3 factorial times 5 factorial, 4 factorial, then 3 factorial. Yan. Kaya, gamitin na natin yung factorial notation sa CalQ. Ayan. So, 4 factorial times 3 factorial ay so 103,680 ways in which 5 large books, 4 medium-sized books, and 3 small books can be placed on a shelf so that all books of the same size are together. Next naman, so 3 cards are chosen in succession from a deck of 52 cards. So find the number of ways this can be done. Una, with replacement. Pangalawa, without replacement. So yung concept ng una, meron kang 52 ways or option or choice para makakuha ng first card. Kung papalitan yung first card mo na nakuha, ng kagaya rin yan, so, meron ko ulit 52 ways or 52 options or choices dun sa pangalawang option or pangalawang card na kukunin. So, times 52 and then times 52 ulit dun sa pangatlo. So, therefore, merong 52 cube ways ng ang pagkuha ng 3 cards chosen in succession from a deck of 52 cards. Without replacement naman, so yung una, meron kang 52 options, so 52 ways. Times 51 ways, ay 51 na lang without replacement, and then mababawasan ulit, so 50 na lang yung pangatlo. Or pwedeng sabihin na permutation yun, no? Permutation of n objects taken are at a time. So, yung total number of objects dun sa without replacement, so 52 taken 3. So, 52 minus 3 factorial. So, equals to 52 factorial over 49 factorial or itong notation na to. And then, cancel yung 49 factorial hanggang 1 dun sa numerator dahil 2 ulit sa denominator. Kaya, 52 times 51 times 50. Next naman ay find the number of n ways that 7 people can arrange themselves. Una, in a row of 7 chairs. So, yung ginagawa natin kanina pa, yung mga permutations, ang tawag doon ay linear permutations. May arrange mo sila in a line. Kagaya dito, yung una is in a row of 7 chairs. Kaya, ito lang yan. So, permutation of 7 chairs taken all at a time. And so, therefore, gaano karaming arrangement yung pwedeng mabuo doon. So, 7p7 kung sa CalQ. So, 5,040 ways that people can arrange themselves in a row of 7 chairs. Yung pangalawa naman ay circular permutation. Kung yung una, pwedeng masolve din yan, diba, ng 7 factorial. Kapag circular table naman, so 6 factorial na lang yan. So, n minus 1 or 7 minus 1 factorial or 6 factorial. At yung 6 factorial ay 720 kung sa circular table. So, next naman ay concept naman ng combinations. So, yung combinations naman, hindi siya concerned dun sa order. Kung yung kanina, concerned siya sa order ng mga objects na in-arrange, dito hindi. Basta magkakasama yung pwedeng kagaya dito, no? So, find the number of combinations of 4 objects A, B, C, D taken 3 at a time. So, dahil magkasama yung A, B, C, hindi siya concerned kung ano yung unang letter na nakalagay. BCA ay tulad lang sa ABC kung combinations or CAD. So, therefore, ang number of combination of 4 objects A, B, C, D taken 3 at a time ay ABC, ABD, ACD, at BCD. Dito, dahil nga tatlo yung letters dun sa per combination, so merong 6 na permutation or 3 factorial. So, therefore, 3 times per combination ay yung total number ng permutation. So, ito yung notation. So, 3 factorial times combination of 4 objects taken 3 at a time. So, dito yung 4 letters taken 3 at a time. So, equal yan sa total permutations or permutation ng 4 letters or objects taken 3 at a time. So, therefore, ito yung form ng permutations. So, pwede natin i-generalize para sa ganitong equation. Or, ito yan. So, n factorial over n minus r and factorial times r factorial para din sa equation para sa, or formula para sa combination. Solve pa tayo. So a class contains 9 boys and 3 girls. Find the number of ways a teacher can select a committee of 4. So, hindi concern kung boy or girl, basta 4 yung pipiliin ng teacher. So, therefore, meron kang total na 12, taken 4 at a time. So, formula for combination, so substitute lang natin yung nasa given. Kaya 12 factorial over 4 factorial times 12 minus 4, so 8. Yan, so 8 factorial ay 495. Ways a teacher can select a committee of 4 from a class that contains 9 boys and 3 girls. So next naman, a woman has 11 close friends. So find the number of ways she can invite 5 of them to dinner where 2 friends are married and will not attend separately. So medyo komplikado. So ito yung ginawa kong solution. So yung una, combination of 9, chosen 5. We're taken 5 at a time. And then yung isa naman, combination of 9 friends. No? So 9 objects, taken 3 at a time. So yung unang part, so dahil kaya ganan, no, 9 lang yung pipiliin, kumbaga hindi natin i-consider yung dalawang friends na married. So ilan yung ways kung na pwede siyang i-invite, yung mga friends na yun, na 5 yung i-invite niya into dinner. So, kaya combination of 9 friends taken 5 at a time. So, ilang ways sila pwedeng makapili ng 5 dun sa 9 friends na yan. And then, yung pangalawa namang option ay dun sa 9 friends, so 3 lang. Dahil yung spot para dun sa 2, para maging 5, ay occupied na nung friends na married. Kaya, 3 at a time lang yung sa isang option. So, 9 factorial, yun yung annotation para sa combination. So, therefore, solve na lang natin. So, 9 factorial over yung 5 factorial, tapos 9 minus 5. So, 4. Plus yung 9 factorial over 3 factorial, and then times 6 factorial. And so therefore, there are 210 ways that a woman that has 11 close friends can invite 5 of them to dinner where 2 friends are married and will not attend separately. And so 210. Next naman, in a 10-pin bowling, how many ways in knocking down the pins will there be if one ball throw is made? Diba, sa bowling, ganito yung magiging solution natin doon. So, yung unang term, so meron kang 10 options or 10 pins, tapos walang mana-knock down. Kaya, ang combination of 10 objects taken 0 at a time. So, walang na-knock down. So, ilang ways yung pwede doon. Sa equation nun, di ba? Parang 10 factorial over 10 factorial lang. So, isang way lang nun na walang mana-knock down. Tapos yung isa, next naman, isa lang dun sa 10 na pin yung mana-knock down. So, ilang ways naman meron doon. Yung pangatlong term, so 2, pang-apat is tatlo, and so on. Yung panghuli, so naka-strike ka, no? Sa lahat ay na-knockdown. So, ilan yung way para dun. So, sa equation, so 10 factorial over 10 factorial, and then times 10 minus 10. So, 0 factorial. Kaya ang matitira lang din dun ay 10 factorial over 10 factorial. So, isang way lang din yun, di ba? Kasi nga na-knockdown mo lahat. Yan. So, pag-a-addin lang natin lahat. So, yun yung notation, di ba? For combination. So, dahil summation, so pwedeng ganito na lang natin gawin. So, yung n factorial, so hindi naman nagbabago yung 10. Tapos, na nagbabago yung nagpo-progress ay yung sa r. So, summation natin from 0 to 10. Diba? Nakita naman sa equation. Kaya r factorial times n minus r and then factorial. So, summation na lang din na notation sa calcu. So, yun yung 10 factorial for numerator. And then x kasi nakalagay sa calculus, so x yung variable na gagamitin, and factorial times 10 minus yung x, then factorial. So therefore, from 0 to 10, yan, so hanapin muna natin kung paano tayo makakapaglagay ng 10. Ayan. So 0 to 10. Ayan, so there are 1,024 ways. And that in a 10-pin bowling, so knocking down the pins will there be if one ball throw is made. So next naman, find the number of ways 6 students can be partitioned into 3 teams containing 2 students each. So concept naman to ng partition. So ito yung magiging solution natin. So combination of 6 objects taken 2 at a time. Tapos yung times. Combination of 4 objects taken 2 at a time. Tapos combination of 2 objects taken 2 at a time. So bakit ganyan? So yung una, so yan yung para sa pagpili sa unang team. So ilang ways na meron 6 students. Tapos kukuha tayo or taken 2 at a time. Ilalagay natin dun sa unang team. Tapos yung pangalawa naman, dahil 4 na lang yung natira, so ilang ways pwedeng makakuha ng 2 students from that pool of 4 students para dun sa pangalawang team. Tapos yung last naman, yung combination ng 2 objects taken 2 at a time. So isang way lang yan. So nilagay ko lang yan dyan para yun din yung solution kasi times 1 lang din naman yan. So kumbaga kung sino yung mga matitira dun sa unang pagpili, dun sa first team, second team. So, sila na yung last. So, sila yung third team. So, therefore, pwedeng i-solve na lang din natin yan. Yan. So, therefore, there are 90 ways in which 6 students can be partitioned into 3 teams containing 2 students each. So next naman, find the number of ways 9 toys may be divided among 4 children if the youngest is to receive 3 toys and each of the others 2 toys. So 4 children, 3 toys yung sa youngest, yung iba ay 2 toys. So dalawang solution na i-represent ko dito. Yung una, kagaya rin ng concept kanina. So, 9 toys, 3 yung unang pipiliin para sa youngest. Kaya, C9-3 or combination of 9 toys taken 3 at a time. Times, dun sa pangalawa namang child. So, meron na lang natirang 6. So, ilang ways yung pwedeng magawa ng pagpili ng 2 toys. Yung pangatlo. So, dahil 4 na lang yung natira, ilan yung ways na makakuha siya ng 2 toys? Ilang number of ways. Kasi sa panghuli, kung ano yung matitira, di yun yung kanya, yung 2 natira. So, times 1 lang din yan. And so, yun yung equation para doon. So, pwede nang isolve. So, therefore, there are 7,560 ways na yung 9 toys can be divided among 4 children, na yung youngest ay merong 3 toys, tapos yung iba ay 2 toys lang. So, isa pang solution. So, parang yung sa concept kanina ng permutation na may magkakatulad or which are alike. So, yung una kasi may 3 na mapupunta sa youngest. Tapos, yung iba ay tagdadalawa. So, ganun din naman yung magiging sagot niyan, syempre. So, 9 factorial over 3 factorial times into factorial, 2 factorial times 2 factorial. So, tulad lang din na 7,560. So, next naman, there are 9 students in a class. So, find the number of ways the students can take 3 tests if the 3 students are to take each test. So, ganun din yung way ng pagsosolve. So, para sa unang test, pipili ka ng 3 students. So, ilang ways na makapili ng 3 students from 9 students in a class. Tapos yung matitira, so 6 na lang. So ilang ways makakapili ng 3 dun sa 6. So yun yung sa combination ng 6 students taking 3 at a time. Tapos yung last, yung matitira, so syempre sila na yung magte-take ng pangatlong test. So kaya isang way lang yun, di ba? Combination, 3 students taken 3 at a time. So therefore, 1,680. So ganun din, pwede natin ulit gamitin yung gantong solution. So 1,680 din. So ginagamit yung mga number of ways kanina, so permutations, combinations. So, ginagamit siya para din, di ba, sa concept naman ng probability na mismo. And so therefore, 1,680 ways. The students or 9 students in a class can take 3 tests if the 3 students are to take each test.